let's write some methods on these ancestor trees using Java. Um, Now, which steps of the design recipe do we get to skip because we're in Java? Haha, none of them, of course. We've done our data definition. We've done examples of the data. You can think about the template. What does the template look like for any function dealing with an ancestor tree? And that's going to get a little bit interesting. I'm going to come back to the template after we write our first function. I think it's easy to see the general pattern after seeing at least one concrete case, but it's going to be the same old, same old. Making examples of the data, by the way, I can put this in this file. I have it in a method called test stuff, and all main does is called test stuff. But okay. By the way, can I go ahead and, I said before, I'll go ahead and make these child objects and I'll stick them in a variable. So again, we'll have the variable marge refers to a structure whose name is, the name field is the string marge, but we won't let that confuse us. String is different than the variable. Can I go ahead and make this new unknown, rather than saying new unknown, new unknown, new unknown, every time I want to do that, can I just use unc, put it in a variable called unc and use that? Sure. And I can do that in Racket as well, right? Okay, so I couldn't, can't say new unknown, or I can say unc there. Now again, the Java side of you is saying, there's a difference. One is creating multiple instances of unknown objects. The other one is making a single object and sharing that reference. And like we've mentioned, if in the absence of mutation, it's kind of a religious question of, gosh, does my program have two objects that happen to look exactly identical in every single field? Or is that one shared object? If you can't mutate it and see if the other one, see if you can get aliasing, then it's a little bit kind of moot. So, okay. So I'll have no preference on that. Go ahead and use one or the other. Same thing. Okay. Yeah, so I can do that. I can name these trees for Mona and Homer and Marge. Say Bart is the new child. Bart, 1975 or 1979, brown eyes. Father or mother's side is Marge. Father's side, Homer. Okay, so those are my test cases. Now let's go write the method size. Come back to the template. Test cases. Okay, I can go ahead and do some test cases here. I'll be a little bit lowbrow. I could go ahead and use JUnit, probably be a little bit more appropriate. I'm just going to put this in here in a method called test stuff, and I'm just going to assert that this is equal to that, and hopefully all my assertions pass. A little reminder, when you run your program, be sure to enable assertions. They're turned off by default. So, how do we write the size method? Size of unknown is going to be 0. Size of Jackie should be 1. Size of Marge will be 2. Marge is the tree that had Jackie and everything else unknown. So there's Marge in there and then Jackie. And that was this, we'll call the size of that tree 2. So the unknowns don't contribute to the size. Only the child objects contribute to the size. How are we going to go ahead and do that? Well, if we put our file or our classes into separate files, then yeah, we're going to go ahead and have the code for child is going to be here, and the code for unknown is going to be here. Which of those is easier for the size method? Unknown. Size of unknown is always 0, right? So let's go ahead and get this here. Size unknown extends AncTree. Okay. Let's get rid of this here for a second. Okay. Ints, so size returns an int, is passed in an object of type unknown, right? Okay, called THIS. I don't get to choose the name of that parameter. In fact, it's done for me, which is why I commented. It's really happening, but I commented it out because it's really there. And the code is pretty dang easy, return 0. By the way, could I go ahead and have a private field, a private constructor here? I guess, I don't know. I guess I could do that. And then I could have a final static field called the unknown. And what does this do? This is now, if I'm thinking with my Java hat on, hey, rather than make 70 different objects, each with 0 fields, I'm going to make one object, and you'll have to, rather than calling the constructor, I made the constructor private, so you can't call it. don't call the constructor, use that named constant, the unknown. This is a pattern, very simple pattern. The singleton pattern. I'm going to ensure that there's only one unknown object made. If I were to make the constructor private, call it inside this class, but then attach a named constant to that thing. I could also make a little getter for that named constant too. So instead of allowing it directly. Anyway, that would, again, off in Java, this is called the singleton pattern. In Racket, so we didn't even bother giving it a name, we just sort of did it. In fact, we didn't even have an object for this, so because we could make our union types. Okay, great, yeah, class, yeah, couldn't get easier, return 0. What is the code for a child object? It is so wide it doesn't fit on the screen. That's not true. We already saw the code for child. It returns 1 plus the size of the mother plus the size of the father. Okay, and again, this .ma.size, this .pa.size. Okay, so pretty straightforward. I put it on 3 lines. Probably should make that all on 1 line. Okay, that's not quite enough to put size in here. If I could put size in child, I need it there. I put a size in unknown, I need it there. That's still not enough to go ahead up in AncTree. When I go ahead, I can start talking about these things here. But here's the problem, or at least one problem, I don't know. I decide, what is the type of Abe? I could have said child, I could have said AncTree. AncTree is more general. I just, for simplicity, I said, here's a bunch of AncTrees. Okay, so I declared all of these to be AncTrees. I could have been more specific. But now Java comes along and says, hey, AncTree, is there a method called size that works for every single AncTree? I mean, yeah, I know you have one in child, and yeah, I know you have one in unknown, but again, maybe somebody else will make some other class or whatever that extends AncTree. They won't provide that method. If I want to say, hey, every AncTree must implement the size method, where do I put that? I put that right up here in class AncTree. And how do we do it? We say we have an abstract method. So it's a size, return type int, make it abstract, says, hey, I'm not putting the code here up in class AncTree. Every subclass is going to have to do it themselves, okay? In fact, if you forgot to put size inside class unknown, you were so eager about child, they put it in child and then hit compile. If you put an abstract here and you had forgotten to put it in a subclass, you'll get an error, which you should, and so it can catch that error really soon, okay? As opposed to Racket, where if you forgot off to check if your AncTree were the size, you wouldn't, or if you handled the unknown case, if you sort of forgot that cond branch, you'd get a runtime error eventually on one of your test case calls, but wouldn't show up before you ran the program. So yeah, we abstract class, and we get errors earlier in this typed system. One of the advantages, or the big advantage of having a typed system. Okay, great. So this now runs, it compiles. So I look here, yeah, and I have a change name declared up here. Let me get rid of that. By the way, where should I put the, that's stuff we will talk about. I tend to put the documentation for size, the purpose statement, I tend to put it at that abstract level, and I don't really need to repeat it in both subclasses, right? It's already clear what the purpose of this is. Look at that thing there. So I can go to class unknown, and I can say, hey, and there's even an annotation they have these days, at override. And this lets the Java compiler know, hey, this method size, I'm overriding a method. And somebody else looking at this code can say, hey, size is, they're telling me size really is declared in a superclass. I should look for the documentation there, perhaps. So, and that's all you need to put is at override before this size method in the subclasses. Okay. So now we do this. Oh gosh. Can't nest comments, right? Okay, so this. Okay. Oh, no, that's the one that I need to disable. Okay. Oh my goodness, trying to just put a comment out something that already had a block comment in it, and Java put me in a world of hurt. Okay. And then we'll do the same thing here. If you ever design a language, Yeah, make your comments nest. No reason not to. The block comments in Racket nest, everything's fine, doesn't cause any problems. Okay, so I have my code for size. And again, think about this diagram we have here. My IDE gets overzealous about removing these arrows. They should not really be there. Okay, method size, abstract up in the abstract class, and then implementation down here, implementation down here. So now, what is the template for any function that handles an AncTree? So we're handling a union type. So what should our template look like? Well, what did our template look like in Racket for a union type with 2 variants? We had a cond with 2 branches. Wait, did I have a cond here? An if-else statement? In fact, the way that this the class is doing it for me, I don't have a cond. Instead, I put some code in one class and other code in another class, and that is the cond in some sense. You go up to any AncTree and say, hey, I want to call your size method, and we know it has to be there, and we know the code is there. So yeah, so our template is easier because we don't have a cond. Maybe it's a little bit tougher because it's separated into 2 different places, 2 different files. And if I had 7 variants that have the same code, really the 7 right-hand sides of the cond branches would be in 7 different subclasses of an abstract class. And it would be mentioned once up in the abstract class. Okay, so yeah, I can talk about what is the template for a template for an Ancestor-Tree. Up in class AncTree, we say abstract function. I don't know what return type to put. I guess I'll put this all in a comment. Func for AncTree, and it's given an AncTree this semicolon. So that's all good, except, you know, maybe I'll stick the word void in there. Void is not a type. It's not that this function returns something of type void. It doesn't return anything at all. So, okay, so it's a little bit inconsistent. But anyway, so void is not really a return type. When I said return type, well, I mean return type or the special keyword void. Okay, so in general, this might be int or some other thing we're returning. So I do that. What is this? So again, we're writing the template. The template is now split across 3 files. I put this in one file, copy it. I'm going to go down to unknown and put in, take out the word abstract, have func for AncTree, and in this branch, I'm going to handle the unknown. And what is the code for that going to look like? ... Okay, I don't know. It depends on what the function needs to do. Okay. Let me just say return ... Okay, semicolon. Okay, great. That is my class unknown. And then finally, what would the template look like inside class child? Oh, I would also have a func for AncTree. Oops. Except this time I'll be given a child. Oh, I got that wrong, didn't I? The type comes first. Child, this. Return, and then what goes in here? Well, it's going to be, yeah, what do we have to work with? Oh, we have this dot name. We have this dot year of birth, this dot I. So I have a string. I might call string append. Who knows? I might call a substring. I have this dot year of YOB. So I might call plus or greater than on that int. I have this dot ma and this dot pa. What are the types of those? Those are ancestor trees. What method might I call? Again, this is now step, what was it, 3C, I believe. Add the natural recursion. Okay, step 3C of the design recipe. If one of the fields you pull out happens to be an AncTree, go ahead and make that recursive call. Now, Is this.ma, is that a child or an unknown? Might be either. That's why we declared that type to be AncTree. So we don't know that we have a child object. In fact, our first example definitely did not. Okay, but doesn't matter if this.ma is a child or an unknown. It is an AncTree. I can call size on it. The right method will get called regardless of what type it is. Java's dispatch will do that for me. Okay, so that's the what the template looks like. Our template doesn't have a con, but a split across all the variants and then one abstract copy up in the parent. Okay, and now we can go ahead and, oh, and I guess I should go ahead and write at override, and I should fix that error I had in the previous file over in the empty. I wrote that type wrong. Oh, that was just a, oh no, oh, here we are. Oh, I did it correctly over here. Okay, so everything compiles, get rid of those errors. My IDE is thinking, hey, because of your test cases happens to have something of type child, I'm going to say that an AncType has a child. It doesn't have a child as a field. Yeah, but one of my methods happened to use a child in it, but that was because I put my test cases in there, really. But okay, sounds good. Let's go ahead, and the next video, I'll let you go ahead and start writing our next AncTree method. What was that? Back in Racket, we wrote size. Then I think we went ahead and wrote change name. Okay, so again, take in an AncTree and the old name to look for and replace every copy of that old name with a new name in the entire tree. So go ahead and write that method and we'll see what happens.